In this video, I'm going to talk about variables in Lantern and sort of generally conceptually. A variable is just a chunk of the computer's memory that we assign a name to, and we use that memory location to store a value that is meaningful to our program. It could be anything. It could be a score, a health, something like that. You could think of a variable as being a shoebox that has a name written on it. So the shoebox here has health written on it. So maybe health is a variable that our program needs to keep track of. So that's all a variable is. It's really just you can think of it as a shoebox with a label on it, and we can put a value in that box, and we can take that value out and change it and put it back in the box. So that's all a variable is in Lantern. So variables represent things like in an adventure game, typically like has something happened yet or not, or what turn is it, or we use them for timers, counting up and counting down. You know, you've got 10 turns to do something, or if you don't solve the game within 50 turns, the reactor melts or something like that. Resources, we can model resources using variables. So maybe you have a battery that burns for 50 turns or something like that, or a torch that burns for 50 turns, or an NPC that has a health or something like that. So we can use them for those sorts of things. And for this first example here, whether something has happened yet or not, that comes into play when we keep track of a score system, when we want a score system in our game. And score is a variable, right? So if the player has done something, then when we calculate the score, we'll say, okay, if the player's done that thing, then we'll give them some points. We'll add some points to our score, which is a variable. There are some built-in variables inside of Lantern. Here are the most useful ones: score, moves, health, turns without light, and game over. Moves is also that's like how long the game has been going on in turns. Turns without light is used for killing the player if you don't want them to be in darkness for too long. And then game over is like, has the player won the game yet? No, that one's fairly obvious. So there's some built-in variables for you already. When you make your own variables, there's some rules, and these rules hold for most programming languages. Variable names can't have spaces, and they can't start with a number. Lantern will not let you make a variable name with a space anyway or a number. It will enforce this when you try to make the variable. It will replace the spaces with underscores. Now, when you want to assign a value to a variable, this is where the assignment operator comes in that we talked about earlier. That's the single equal sign. So the single equal sign means assignment. It evaluates the expression on the right-hand side and puts it into that target location on the left-hand side, right? That shoebox. So let's take an example of like assigning a value to a variable, like our health. Maybe we do something in our game, we drink a potion, and we want to set our health back to 100. So this says health is now 100, done. The semicolon means done. So this expression means take the value on the right, which is 100, and stuff it into the target location on the left. So that shoebox or health is now going to be 100 when this assignment executes. So the single equal sign means evaluate the expression on the right, put it in the target location on the left. That is the best way to understand the single equal sign. So what if instead of setting a value like that, like setting it to 100, what if you wanted to add an amount to a variable or subtract an amount from a variable? What would that look like? Well, we'll still use the assignment operator. We're going to take that value out of the shoebox, add or subtract some amount to it, and then put it back in the shoebox. So what does that look like? Well, if we wanted to subtract 1 from our health, and so notice the double slash. If you watch the earlier video, that means that this is just a note. I'm just saying what this code does. It subtracts 1 from health. So remember, the single equal sign means evaluate the expression on the right and put it in the target location on the left. So we're going to take the value of health, whatever it happens to be, subtract 1 from it. And that's the answer. That's our result. And then we're going to put that back in the target location on the left. So we're going to take the value out of the shoebox, subtract 1 from it, put it back in the shoebox, right? So there's health. We're going to compute whatever health minus 1 is, and then we're going to put it back in the shoebox, right? That's what the single equal sign means. That's what the assignment operator means. Evaluate the expression on the right, put it in the target location on the left. So whatever health was before, it's one less now, right? So if it was 100 before, now it's 99. If it's 1, now it's 0. So that is how you change the value of a variable. If you wanted to add something to a variable, it's the same thing, right? So let's say we want to add 10 to our score. Now we are going to do the same thing. We're going to take score out of the shoebox, add 10 to it, and put that value back in the shoebox using the assignment operator. So take score, add 10 to it, assign it back to score. Take that value out of the storage location, add 10 to it, put it back in the storage location. So this is how you would add to a variable. So score equals score plus 10, score equals score plus 1, something like that. That will take the value out of the box, add something to it, change it somehow, put it back in the box. All right. There are some shorthands for this because we do this a lot, like minus equals and plus equals. These are short forms of what I just showed you. So health minus equals 1 is a shorthand for health equals health minus 1. So minus equals is just a short form of that. Health equals health minus 1. This is just shorthand for that. I see people do stuff like this. Health equals minus 1. Okay, you just set your health to -1. That is not what is going on here. We want health minus equals 1. Or sometimes people write health minus 1. This doesn't do anything because there's no assignment. You're going to have the assignment operator in here at some point. This takes health and subtracts 1 from it and then does nothing with the result, right? To store the result somewhere, you need the single equal sign. So health minus equals 1 is just a short form for health equals health minus 1. And score plus equals 10 is a short form for score equals score plus 10. And if you can't remember those short forms, then just remember the long forms. Health equals health minus 1. Score equals score plus 10. There's nothing wrong with using the long forms. All right. Now, there are some other shorthands, some other shortcuts. Because adding 1 and subtracting 1 to variables is something that we do so often, there's a special notation for that. So minus minus after a variable name means subtract 1 from it. And plus plus after a variable name means add 1 to it. So this subtracts 1 from health, and this adds 1 to score. These are shorthand notations of health equals health minus 1 and score equals score plus 1. So health minus minus semicolon subtracts 1 from health. Again, if you can't remember that, then remember the long form. That's fine. It works too. There's really nothing different going on here. The compiler is just rewriting the stuff for you. It's expanding the short form into the long form when it goes to build the code. So let's talk about Lantern variables specifically. Variables in Lantern are a little bit different from other programming languages. You declare them on the variables tab. There is no, normally in a programming language, you declare the variables inside of your code. Lantern does not do it that way, and that is because of the very, very primitive processors that Lantern is trying to target code for. It just does not, it's not real super practical. So there's a tab for creating the variables, and when you make them, they are global, which means they are visible or usable anywhere. So the health variable, which is one of your variables, is accessible from all of your functions. Every function you have can access the health variable. When you make a variable in Lantern, it is accessible to all of your functions. There are no local variables in Lantern. So local variables would be variables you make inside of a function, inside of your code. Global variables are declared outside of your functions and are accessible to all of your functions. So global variables are generally considered to be bad, although like Python still supports them. So that's just something a little bit different about Lantern. You don't declare your variables in your code. There are no local variables. Variables are made on the variables tab. But again, it's a little bit different than if you're writing in Python or Java or something. But it's fine. You get used to it. Now, range of values. This is another thing. It's another limitation imposed by the fact that Lantern is trying to target these ancient computers. And also, I was lazy and just trying to get this thing cranked out as fast as possible. So Lantern variables can only store a number between 0 and 255. This is because variables are stored as a single byte of data, 8 bits, 8 ones and zeros. The biggest value you can have with 8 ones and zeros, it would be all ones, 8 ones. And in binary, if you figure out what that is 255. So 255 is the biggest value you can have in a variable in Lantern. And there's no negative numbers either. And again, this was just for simplicity, and so I could get this thing cranked out as fast as possible. And it turns out this doesn't really pose any problems at all in an adventure game, as long as you just kind of keep your score between 0 and 100 or something, or you don't let the player try to have 1,000,000 coins or something like that. Or as numbers, variables in Lantern cannot be bigger than 255, and they cannot be less than 0. And that was just a design choice to keep everything simple. Now, some weird things can happen though because of this design choice that I made. If a variable contains 0 and you subtract 1 from it, it underflows. It underflows and rolls under, whatever you want to think about it, and it becomes 255. So it's like if you had a clock and it was at 0 and you backed it up, now it's at 99999, like a stopwatch or something like that. Well, stopwatches don't use 999s, but it's like if your car was at 0, it was a brand new car right off the assembly line, and somehow you backed it up. I don't know. That's not true. Anyway, if you subtract 1 from 0, the number underflows and becomes the biggest possible positive number that it can store. And if you have 255 and you add 1 to it, it overflows, it rolls over. This is like your odometer on your car rolling over, or a stopwatch rolling over. It goes back to 0. So it becomes the smallest number it can contain. So weird things can happen if you're like, oh, I subtracted some random number from the player's health, and now the player's health is 253 when it was 1 before. Well, that's what happened. You underflowed. Or something is supposed to happen at turn 5 in the game, and then it happens at turn like 300 in the game. Again, that's because a variable overflowed. All right, so weird things like that can happen, but all the code stubs are designed to protect you from all this, and you shouldn't ever run into this. Now, let's say, how does Lantern actually protect you from this sort of weird stuff? So let's say you have a variable called health, and it's set to 0, and you subtract 5 from it. Well, now it's going to become, if health was 0, and now it's going to become a very big positive number. So basically, we're going to subtract, we're going to assume that our health can be between 0 and 100. And if we subtract from it, and then health is suddenly bigger than 100, well, then we know that it overflowed, and we'll set it back, or it underflowed, and we'll set it back to 0. So it's just stuff like that. Like if you add something to a number and it becomes less than it used to be, then you had an overflow condition. So Lantern, when the code snippets will actually put in all this stuff to protect you. But that's just, just be aware that the range of values you can have is determined by how big a storage location you have. And Lantern has very small storage locations. So the biggest number you can have is 255. The smallest number you can have is 0. That was just a decision that made it easy to target these like ancient 8-bit computers. There's a famous urban legend that may be true. I don't know. The Gandhi bug in Civilization. Gandhi is supposed to be a pacifist, or he was a pacifist. But in the game Civilization, he would frequently go rogue and nuke people. So what was happening is in Civilization, supposedly, they had a very similar system for handling the aggression level of a leader. And Gandhi was not very aggressive. His aggressiveness was 0. And when a civilization adopts democracy, they become less aggressive. So if you subtract one from zero and you're not using negative numbers like Lantern does, then it rolls over and it becomes the maximum possible positive number. And then Gandhi becomes the most aggressive you can possibly be in the game and just starts dropping nuclear weapons. So that's the Gandhi bug. It's an underflow error caused by using variables that don't use negative numbers. So just be aware that's just kind of a weird thing that happens in Lantern. Variables can only be 0 to 255. Now, here's a really cool trick. This is really helpful when you're writing your game. Let's look at a game, and I'll close the test tab here. So here I'm on the variables tab. Here's like some built-in variables that you get when you create a project. And then I have added like a ton more over here under user defined variables. And these are keeping track of like, you know, how many turns has the spider been angry? Have you done certain things? Have certain things happened in the game? Have you received points for doing certain things? Just scorekeeping or housekeeping, like what's going on in the game. Now, if I run my game here, and I know you can't see the entire picture. This is really cool. All right, so here I am in my little test window. I'm going to type VARS and hit enter. And it even tells you right that to dump out a game's variables, type vars and hit enter. And I'm going to hit enter. It will dump out my all the variables in my game. And there's a variable here that says talked to painting. So I'm trying to keep track of whether the players talk to the painting or not. So let me go south here, and there's a painting. Let me say talk to painting. And I talk to the painting. Let me type vars again. And you should see now that talked to painting has been set to 1 by my code. So I can verify that my code is working properly by typing this command and dumping out the variables and seeing that the state of the game has changed. Oh, I can see. So I'm not supposed to have this spell right here, but so I got to change that. All right. So here I'm using variables to say like whether or not the player has access to certain spells, and I can see right there that value is wrong, and I probably put it in there for testing. So anyway, that's Lantern variables. A rough edit there, but just remember that plus plus minus minus, add 1, subtract 1, and type in vars to dump out your variables. Variables can be 0 to 255, and all your variables are global. All of this is on the reference sheet that I gave everybody, and that's basically all you need to know about variables in Lantern.